want to talk just a little bit about how we put Clima together and some of the designs that we made from a coding perspective. And you've seen lots of pieces of the Hack Kit and the Pro projects, but let's step back and say, okay, well, how are we actually building this? And the first thing to think about when you're building IoT solutions is, generally speaking, unless you're doing a lot of clever coding, you're doing single purpose applications on the hardware. So yes, there is an operating system under the hood, and it does exist, but it's not an OS like we think of normally with like Windows. It's not a multi-user, multi-application environment. And really under the hood, the app we run is the runtime. That runtime then kicks off the application and push the board. And that's actually very freeing because you don't have to code defensively worry about things like multitasking. For those of you that come from a mobile background, the Android lifecycle can be very complex, and you're managing managing both parts of the application that are your visuals versus background services, and that lifecycle gets very complex. The lifecycle is drastically simplified on Meadow, and that's really beautiful. And that allows you to do some fun things. So you will just see some decisions like when we do things like initialize the network, we can do those things asynchronously. You've seen the APIs. Let me just jump in over here. But because we know this is a single purpose application, we can make the choice to say, you know what? Yes, I can initialize the Wi-Fi asynchronously, but I know my application in this case is dependent on it. So I'm going to wait on that. And that is an okay design decision for this type of application, because the user isn't trying to switch over and play solitaire on the board. The user is just running this application. And so we can say, hey, well, we're going to have that performance penalty for starting up, but we know things happen in chronological order, and we know the exact state as we run each method or each stage of our initialization. It also allows us to do other fun things in terms of how we reach other services or dependencies in the application. Again, modern developers might use techniques like service injection, for example, or more complex management. We don't have to worry about that. We can build those kind of things. We can find lightweight injection patterns we use in C#. It's the beautiful thing of the language. But we can also use some more basic patterns. And one thing we've chosen to do on a lot of these is actually use singletons. And let me find a good example. I think the data access layer in Clima Pro is a good example of this. And so in this case here, we've opted to use a singleton because we know we're only going to have one database. We know there's not going to be anyone competing for resources in terms of file allocations. And so this is actually a safe strategy, and allows us to use, where we might use like a service locator pattern in other platforms, we don't have to be that fancy. We can have a singleton, we can expose that public property, we can get to the instance of our local database from anywhere in our code. Now, some people might say, hey, I don't really like having that sort of effectively global, and that's, again, a decision that we can make as developers. But in terms of a performance, memory management, or competing resource strategy, this is absolutely a fair game to use. And again, for those
also, so it's also important, like, for the life cycle to not have multiple instances of the local DB manager. If we have one instance throughout the lifetime of the app, then we're good to go, right? Because in other places of the application, we might need to read, or we might need to update or create or add records. We can do that with this singleton class that is already there, available throughout the application.
Yeah, thank you. That's a really important point. Now, we can talk design patterns, and you find me 10 developers and I'll find you 10 opinions on how to structure these kind of things. But for sure, absolutely, we know that we're not going to have multiple instances of DB manager. We want a single instance of it. And this is where the lazy singleton pattern is really powerful. It also allows us to do great things like, we talked about making that design decision that we're going to front load the initialization of our Wi-Fi network. We might take that time penalty because that's critical to our application. It's a decision that we make based on the needs of our application. But in this case, we might want to get some things up and running before we take the performance penalty of instantiating our data structure, our data manager. So in this case, this is where we can do the lazy loading. We load it once on demand as we need it, so we can let the rest of the application start up. Again, it's C#, it's .NET. We can do things in parallel. The platform is capable of it. We saw that earlier today. We had the wait cursor running. We're updating our display while waiting for the Wi-Fi to initialize. But really nice. jump in, please.
Sorry, Adrian. I just wanted to say that another really cool feature that I always constantly bring up in every session is we have this thing called watchdogs. And the watchdog is the functionality in our boards that, if you have these boards in the wilderness, maybe even your Clima, it's sitting on in the backyard, and it's up in a post or something. If that application tends to fail given of power outage, or there was an exception occurring during runtime, the watchdog, it monitors your status of your application. So in case the application crashes, it'll just resume the application once again, just rebooting itself and restoring and grabbing all the latest state of your app and start getting the app running right away. So you don't need to, climb a tree or anything with your computer and start redeploying again. No need for that. You'll just leave the watchdog, just keep track of your application's health to make sure that it's running at all times.
Yeah, and thank you. That's a really important part of the application lifecycle. So I think it is simplified compared to other platforms, but unlike web and mobile, where you have very complex patterns, it is generally up and running or not. But we have that fail-safe. So where we might have inconsistent power or other reasons the app gets down, gets reset, we can bring things back up and rehydrate. Beautiful.
Perfect.
I'll talk about a few other things, but generally speaking, what we've decided on from an architecture and the coding perspective is to break things down into services. And in which case, you saw this earlier when we talked about the Meadow Pro. We've got the climate service where it's going to view the interactions with our, sending our data over HTTP, where we're uploading to an external server. And you'll see the climate service as encapsulation. You'll see something very similar with Bluetooth, where we set up the Bluetooth server. And again, similar to our database, where we've chosen to use the lazy pattern here. Again, it's a singleton. You've got a single instance. We know we're only going to load one instance of it. We load it on demand. Again, a really nice pattern. We don't have to front load the instantiation when the app starts up, but we'll take the load time as needed for Bluetooth. Now, one thing that gets really interesting on IoT is where you're interacting with the end user, and it is that interface. And for those of you that have been around web and mobile, we often think about the UI, and we say UI, what we really mean is display things to the user. And that can very well be the case here, but we're going to have interesting things where our UI might actually be comprised of, well, it could be displays. We might add physical buttons or joysticks. We might have a touch screen that we bring those capabilities, or we might have other ways for the user to send data into the device, and we might have other ways to get data back out. Sound is another interesting one where, typically on a mobile device, you've got a common audio API. And for those of you that kind of look at these lazy instantiations and go, oh, that feels wrong. Well, you know what? It's actually not that different than you think about how we do it on mobile, where we have a common context for our graphics displays. We have a common context for our audio. And so here, well, you're in control of it. But because you're configuring the hardware, you actually get control how and when you get to these services. And I'll pull up the display controller quickly here as well, just as an example. But notice in this case, we've done a few things where we've encapsulated, you saw this earlier, the display in the graphics library. One thing I didn't touch upon is actually an additional UI level, and that's something called text display menu. Won't go into that right now, but a really great way of adding a simplified menu user interface, works with graphics libraries, works on all pixel displays. Could talk for days on this kind of stuff. But we've encapsulated the menu, the UI, the graphics, and the display driver into the display controller. So it's an encapsulated unit that is really our primary point for our UI. And then with the menu, we've chosen to expose methods so we can inject the events from our buttons into the menu. So we've got a selection, and there's actually 3 buttons on the hardware. Again, take a look at the source code to dive deeper. But there's an argument made that we could actually encapsulate all the UI in this controller as well. In this case, we made a design decision to make it the display controller. So it's the display of the menu, it's the visuals, but you could actually make a UX or a UI controller as well and bring that other hardware in. I think with that might be a great place to leave it. We'll come back and talk a little bit more about the overall architecture of Meadow, understand the technology stack. But again, I think keep in mind, single source, encapsulate functionality, and you have full control of your object lifecycle. And so patterns that you might not use on other platforms because of the complexity of a multi-user, multi-application environment, you actually don't have to worry about on IoT, which gives you the gist of the encapsulation, the singleton, and lazy loading.
Yeah, I also want to say that remember, we are in beta and we are trying to get things more stable. And so even the state of the architecture for Clima is in this state right now, but we're bound to just making it better over time. So there might be some room of improvement on certain places. And so expect more changes on the Clima. So, or even it's open source, right? So people can also do their contributions and, trying to propose different ways to make the architecture more stable, more robust, and more maintainable, which I think everybody wins.